So I came across this fascinating paper that claims to have found the universal blueprint for how anything complex actually survives over time. We're talking about everything from a single cell all the way up to an entire civilization. Okay, let's dive into this.
Now, this might sound like a riddle, right? What do a living cell, a stable democracy, and a safe AI all have in common? Well, according to this new research, they all rely on the exact same hidden mathematical architecture. It's like a set of rules they absolutely have to follow, or they just cease to exist.
To really get our heads around this blueprint, we first have to understand the one fundamental problem that every single complex system is constantly trying to solve.
And that problem is, well, it's brutally simple. Don't die. I know, it sounds pretty obvious. But think about it for a second. Staying alive in a chaotic universe where everything is constantly trying to fall apart, that is incredibly difficult.
The paper gives these vital necessities a name: substrates. You can think of them as the absolute, non-negotiable bottom lines. For your body, oxygen is a substrate. For an economy, it could be energy. They are the core components that simply cannot be allowed to fail.
So as long as a system manages to keep all of its essential substrates above those critical failure points, it's in what the paper calls a state of viability. It's like a safe operating zone. The moment it strays outside that zone, the whole system collapses.
Which brings us to the really big question then. How on earth does a system make sure it stays in that safe zone, especially when it can't see everything at once and it's constantly getting hit by unexpected problems?
Well, the one thing you don't want to do is rely on a single central monitor to watch over everything. That's just a recipe for disaster. It's fragile, it can be tricked, it can be corrupted, or it could just plain fail, leaving the entire system wide open and vulnerable.
So the solution, as this paper proves, isn't one perfect monitor, but a team of them. And you can see the difference right here. A single monitor leads to catastrophic failure, but a team of distributed monitors, that allows for what's called graceful degradation. One monitor can fail, but the whole ship doesn't sink.
And this gets us to the very heart of the blueprint, a structure called a K-cover. It's a really simple but powerful idea. It's a mathematical guarantee that for every single one of your critical substrates, at least one independent monitor is watching it. In other words, there are no blind spots.
And here's the real kicker. This K-cover structure isn't just a good idea. It's a mathematical necessity. The paper shows that systems don't choose this design because they're smart. It's the only design that survives long enough for us to even see it. Any system that doesn't evolve this way simply gets wiped out by selection.
But it gets even cooler, because this K-cover blueprint doesn't just help a system survive, it actually creates an engine for improvement and growth.
The paper calls this the network chain reaction. It's this incredibly powerful feedback loop where safety and growth actually fuel each other. And here's how that chain reaction works. First, being safer means you're not constantly putting out fires, so you have surplus resources and time. Then you reinvest that surplus to make your monitoring even better. Better sensors, more checks. That better monitoring then lets you grow and experiment more safely, which in turn leads to even greater safety and more surplus. It's this amazing virtuous cycle.
So the crucial point here is that stability and progress become completely linked. A system that gets safer also gets better at advancing. It literally accelerates its own success. All right, so this brings us to what is easily the most mind-bending part of this whole theory. What happens when a system becomes intelligent enough to actually understand this blueprint?
Well, the paper models reality in layers. You've got basic physics at the bottom, L0, then resource stocks at L1, then the operational rules of the system at L2. But at the very top, at L3, is the system's most abstract and powerful substrate, its own ability to learn and adapt, its intelligence.
At some point, a self-aware system will realize that its own mind, its ability to learn, to repair itself, is just another critical substrate. And just like all the others, it needs to be protected with the exact same K-cover blueprint.
This recursive insight is called SCAP, and it's a profound idea. It means that intelligence persists not by making some moral choice to protect itself, but by recognizing that protecting its own thinking process is an act of pure, logical, existential self-interest.
Okay, so let's zoom out. What's the big takeaway from all of this? Why is understanding this mathematical blueprint so important?
Well, the most crucial point is that this framework isn't a prescription for how we should act. It's a description of the mathematical reality of what endures. It's not about altruism, it's about enlightened self-interest.
It's not a design you should choose to build, it's the structure that inevitably emerges because all the other ones fail.
And this isn't just an abstract theory. Once you see this K-cover pattern, you start seeing it absolutely everywhere. It's in the redundant metabolic pathways in our cells. It's in the separation of powers and democracies. It's in ecosystems, and it's in how we think about building safe technology.
And that leaves us with a final, pretty provocative thought. If the rules for survival are literally written in the language of math, are our own systems, our institutions, our technologies, and maybe even ourselves actually built to last?